My name is Pedro Duarte.
I'm Pedro Girão, and this is our final project for the Projeto de SIstemas Digitais course. We are master's degree students at Electrical and Computer Engineering Department in University of Coimbra.
Our creation process follows this logic. The first step, defining a system and adding the CPU, peripherals, memory and user logic, is done in Qsys, which offers a variety of peripherals and other predefined circuits that we can use in order to ease the system engineering stage. We can then generate the HDL and use Quartus II to implement it on the DE2 FPGA board. After having a full hardware system, we can use Altera's provided tool, Eclipse software build tool, to aid the software development and deployment on. This is the projected system overview with most of the components we used and that you will be able to see in the Qsys system presented in this video as follows. Enjoy.
Hello everyone, this is our final project for Projeto de SIstemas Digitais course. This that you are seeing is the Qsys hardware system, which we have already programmed the DE2 board with. You can see here the PLL for the components, the video components as the FIFO, the buffer, DMA, the resampler, the controller, the scaler, the SRAM, the SDRAM where we're going to store our program, the timer, the character buffer, finally the alpha blender, then the SD card where we will store images to be read from the board and displayed in the VGA display, the ID, the input-output for having both switch input and LED output in the board. This is, as I said, already programmed. You can see the screen doesn't have any information right now. You can see our software in Eclipse software build tools. So in our software we have a quick reference list for the addresses that we defined in the Qsys system. This way we can use them in our code. For example, you can see it here in the switch and LED initialization. We then proceed to open the devices, both the character buffer, the SD card, and we check that an SD card is on the slot and that the format is FAT16. This is very important, otherwise it will not be correctly read. We clear up the screen, the character buffer, and then while we have an SD card, we will check if either there is a value on the switches that is different from 0, and if it is different from 0, then that will be the only picture to be displayed. Otherwise, we will continue automatically to the next picture until we have to come back to the first one. Just the code you are seeing right now is our cycle that checks if we have reached the last one. If we have reached an image file, then we will put its name on the screen and we will jump its header and start writing. This is the conversion from 24 to 16 bits, and it is written pixel by pixel. You can see here the VGA box function, which writes each pixel on the screen, and you can see here the address for the VGA pixel buffer. We will now compile and run this on the board, and as soon as it's good to go, it's now running on the board. You can see here this is the screen clearing up,
And it doesn't display any image whatsoever, as there are no files to be displayed. The card is empty. The card is plugged in, but it's empty. So we can take the SD card, plug it in the computer, and in the computer we already have some bitmap image files to be displayed. So we can open the card and pass the pictures, the bitmap image files, onto the card. The images are now on the card. We can now extract the card. we can plug it back in the board, restart the board. Now the images start being displayed on the screen. As we can see in the console, it detected the card, it detected the FAT16 file system, and say it's trying to open, and it's correctly opening the image. Since this is an image with a white background, we cannot see it, but in any other image, we also write the image name on the bottom right of the VGA screen. And so this keeps displaying the images in a cycle on the VGA screen. The display rate is quite slow since it's reading directly from the SD card, and the SD card read operations are quite slow as well. We have added some user interaction to the system, so we can cycle through the photos with the switches. We can introduce the image ID in binary in the switches. We will display the 7th image next, and the 7th image is being displayed. Now the next picture will be the first, since there is only one switch on, and this is the first image, the Altera image. It's currently displaying the 8th image. We have turned all the switches off, and since all the switches are turned off, it will present the next image, the 9th image.